Hello all, welcome to a new video on logic design. In this video, I am going to discuss an important topic, conversion of gray code to binary code. In my previous lecture, I have explained how to convert a binary code to a gray code. You can expect questions related to this topic in your GATE exam or any other competitive exam. So this video is about the conversion of gray code to binary code. If you are new to my channel, check out the videos on the selected topics from the course of Logic Design and the solutions of the previous year question papers of Logic Design. The links of all those videos have been given in the description box. So without further delay, let's get started. Let us see how to convert a gray code to a binary code. In order to convert a gray code to a binary code, we have to use the truth table of XOR gate. So this is the logic symbol of XOR gate. This XOR gate consists of two inputs A and B and one output. So these are the four inputs, that is four combinations of 0 and 1 to the XOR gate, and these are the output. So what is the logic of XOR gate? When you give two similar inputs to the XOR gate like 0 0 or 1 1, you get the output as 0. When you give two similar inputs, that is 0 0 or 1 1, suppose A is equal to 0, B equal to 0, the output is 0. Suppose A equal to 1, B equal to 1, the output is 0. And when you give two dissimilar inputs like 0 1 or 1 0, the output is 1. That is, when A equal to 0, B equal to 1, the output is 1, or when A equal to 1 and B equal to 0, the output is 1. So this is the logic of XOR gate. So we are going to apply the truth table of the XOR gate in order to convert a gray code to binary code. Now let us do an example. This is the given gray code. You have to convert this gray code to binary. 101101101 is the gray code. You have to convert this to binary. For that, we have to use the truth table of XOR gate. So what is the first step that we have to follow here? The first step is you have to write the first bit as it is. Which is the first bit here? 1. Write 1 as it is. The second step is XOR this bit with the next bit of gray code. That is 1 XOR 0 will give you 1. What is 1 XOR 0? 1 XOR 0 is 1. Write that here. Now this result or output should be XORed with the next bit of the gray code. That is 1 XOR 1. 1 XOR 1 will give you 0. And from here onwards, you have to repeat the same process till the end. So this output is XORed with the next bit. That is 0 XOR 1 will give you 1. 1 XOR 0 will give you 1. 1 XOR 1 will give you 0. 0 XOR 1 is 1. 1 XOR 0 is 1 again, and 1 XOR 1 is 0. So this is the binary equivalent of the given gray code. This is your gray code 1011011011, and this is the binary equivalent 1101101110. Now we can cross check whether the binary value obtained is correct or not. For that, we can convert this binary back to gray code. So what is the steps that we have to follow? The first step is write the first bit as it is. From now onwards, we have to XOR the bits with its adjacent bits. So the first bit is XORed with its adjacent bit, that is second bit. You will get 1 XOR 1 as 0. Now 1 XOR 0 is 1. 0 XOR 1 is 1. 1 XOR 1 is 0. 1 XOR 0 is 1 again, 0 XOR 1 is 1, 1 XOR 1 is 0, and 1 XOR 0 is 1. So this is your gray code. So we can confirm that the binary value obtained here is the binary equivalent of the given gray code. Thanks for your time.